After watching the manufacturing process of the giant warship's internal shaft, I finally understand why only military-industrial ships can be called true forging kings. Just a seemingly insignificant lump of iron requires 5 or 6 people to guard against sparks over 5 meters high, and it takes thousands of forging presses to transform it. The moment the finished product is unveiled, its craftsmanship details will absolutely exceed your imagination. What appears before you is the raw material, high-carbon steel, corresponding to the National Standard 20C mark. It is often used to make various fasteners for temperatures below 250 degrees Celsius. Before the forging begins, it is also heated by an electric furnace, bringing the temperature to a level that is beyond the reach of ordinary people. Then it is carefully laid flat on the ground, but judging by the degree of shaking, this is not safe at all. Though fortunately, it did not fall over. In the blink of an eye, the measurement is complete, and the scorching metal looks truly spectacular from the outside. Although it is large in volume for transportation, it seems very easy. By simply sitting in an air-conditioned room and remotely controlling the mechanical vehicle, you can easily lift various types of steel weighing tens of tons, slowly lifting it to the front of the brake. Here, with just a gentle touch, a noticeable groove will appear on the outer layer, and all the workers need to do is use a broom to sweep away the fallen oxide scale. Then, apply pressure to the steel billet with a flat heavy press. After several rounds of repeated forging, the steel billet meets the basic conditions for forging, and workers holding iron plates begin to take action. It's not hard to see that the simpler the tool, the more it can reflect great wisdom. Just like the old steel plate in front of us, Lenny. If sold to a scrapyard, it would only be worth a wash basin. But if used for protection, the boss would even give a bonus. Once one side is cut, the rotation is initiated to start cutting the other side. The reason for manual cutting is mainly to make a mark. Now let's see what the mark is used for. You can see that each time the hammer drops, it targets the marked spot. This also means it mainly serves as a positioning function. Only in this way can the steel billets be connected head to tail and ensure the dimensions consistently remain within the same specifications. After forging on one side, the process begins on the other side. From the footage, you can see that the outer layer of the steel billet changes at this moment, becoming more rounded compared to the initial sharp edges, and there are no longer any marks for comparison. This requires a skillful coordination between humans and machines. For example, the worker in the footage plays a role that, after several rounds of effective arm lifting, manages to forge the steel billet so neatly. Without tens of thousands of arm lifts, it would be difficult to forge the axle in front of us, and then proceed to the front to handle the details. First, the single segment is inserted deeply into the mold, then pressure is applied while rotating. In less than 2 minutes, the surface will exhibit a mirror-like shine, followed by fine-tuning by an experienced master. At this point, the inner axle takes on its general shape. Next, the process moves forward to begin tempering. The main purpose of tempering is to eliminate the internal stress of the steel billet, thereby improving the toughness of the steel structure, which is extremely unstable. This also indirectly increases the possibility of cracking. Therefore, only heating can eliminate the stress in the steel structure. In the blink of an eye, the heating of the steel billet is completed, and it is transported forward by the overhead crane to begin cooling. When the steel billet makes contact, a raging fire will ignite around it. Once this process is completed, the next step is finishing, which is also the most time-consuming step in this round. Because a total of 3 lathes need to be changed, and dozens of cutting tools are required to machine the bow and arrow so precisely. This item plays a significant role, but how can military components lack quality inspection? Non-destructive testing begins, and it is said that it must pass more than 3 rounds of quality inspection before leaving the factory. Friends watching this, do you know where exactly this big guy is used on the ship's body?